Hello, everybody. This is Python for Linguists with another video. This one on functions, on really how to write code that looks a lot more nice and structured than what we've done up to this point. So there's not going to be anything, we're not going to learn how to do anything new in this video, but we're going to learn how to write code that achieves the same things in a much more structured, sort of long-lasting, sustainable kind of way. That's what this is all about. There will be plenty of code examples and exercises, so just be ready for those as well. And let's dive straight in. Um, the whole purpose of functions is to modularize your code. And the idea here is as you write more and more complex, complicated scripts or applications, you may want to keep individual pieces of code separate from one another, kind of treat these as coherent internal bits of functionality that you can then use and maybe reuse at various places in your code. And in order to define these separate bits, that's what we use functions for. Maybe you can think of this as kind of the car manufacturing process, where there's a lot of kind of really low-level ingredients, but they all get kind of stamped into individual parts first, and then a machine knows how to assemble these already assembled individual parts. That's kind of like how writing functions in Python works. Why do this? There's a number of reasons. Um, if you need to use a function over and over again, or a piece of code over and over again, if you write it in a function, basically it's going to have a name, a couple of characters that just tell Python, refer Python back to the whole sequence of code you want to execute. And you can kind of, anytime you want to execute it, can basically just tell Python, do this now, without having to retype the code. Don't repeat yourself is a very fundamental principle in coding, and functions are a big helper in that sense. You don't have to repeat the code over and over again. You write it once, and then you can use the shortcut of a function definition or a function call every time you want to use the code again. If you need to make a change to a block of code, you can do that directly where it's defined, and you don't need to sort of look where it is and then maybe find it in some indented block of code where you then need to uh, be careful about the order of indentation and the scope under which things go. So you have a much more direct way to be pointed to where you want to fix code. If you want to change the order of code, it's also nicer if you just swap one function call around rather than, several indented blocks of code. And then with appropriate function names and documentation, you'll also have a good idea of what your code is doing without understanding every tiny bit of it, right? If you have a function that's called text to word list or something, you probably have a good sense of what that function is going to do. Um, and if you documented it, you'll be able to see exactly what it does. And that means you and also somebody else who doesn't maybe know a lot about Python can use this function and still do something with it. So how do we do all this? It's very simple, defining one function here in a two-liner. 2 lines is the minimum that you really require to define a function. And what you see here is def mean list, colon, and then the indented block of code saying return sum list divided by length of the list. So what's going on here? The first element always is def, which is definition or define. That initiates the definition of the new function. And that definition basically is bracketed off with this colon, right? So you do def, and then whatever happens in this line, it ends with a colon, and that's sort of the key architecture of your first line of any function definition. And then in addition to the def and the colon, there's the name of the function, which I'm calling mean here, the mathematical mean or arithmetic mean. And then something within parentheses. So that's the function name. It's kind of like a variable name. You can choose what you call the function. Nobody's going to penalize you if you call it Mary Poppins, but it's not very helpful to you probably if you want to read the code in 3 months. You probably want to call it something that gives a hint at what the function does. And then in the parentheses, you can give the function arguments. The simplest way to do this is without an argument, right? You can have something like def hello world, no argument, and then just basically in that function give it the print statement, print hello world. That's possible, and then you call that without any argument and it does something. But very often, um, the way a function works is basically, it's kind of like a mathematical function, right? It takes an input parameter and sort of goes through operations that do something based on this input and return an output. So the input here essentially then is what's given to the function as a parameter, and then this is picked up down here, right, in the return statement. So the sum of that list and the length of that list is used. So I'm getting a little bit ahead of myself here, but yeah, the parameter here kind of can be thought of like a loop variable in a for loop, right? For x in and do something with x. That's kind of the same with def mean list, do something with the list. Whether we call this list again or Peter, doesn't matter. It needs to be internally consistent. So this thing needs to be the same as this thing. And then Python knows whatever the function has been fed is being worked with here. And note that Python doesn't check whether what you expect, what kind of object this is, whether it is actually that kind of object. So it's very laissez-faire here. It just kind of takes whatever the user feeds it, and that means if I feed an integer to this, and then I want to do return some integer divided by length of the integer, that's going to throw an error message. But we don't get the error message until Python actually runs into a problem. Typical Python behavior. Other programming languages very often would instead yell at you right away when you feed the function an object that isn't expected. All right. Final important element is the return statement, right? This is the only really new new command that we're encountering here. Return and then whatever is in these brackets. That's basically once we call the function, once it's defined and then we call it, it's just like calling a variable and retrieving the value stored under that variable. Basically, the return statement is the value that the call to the function will give us back. And like a function name, if we just sort of call the function, we get the return statement. That isn't even going to show if we execute this as a script, right? So we then want to do something with that return value. And then something also to note about return statements, whenever a function, sometimes they get more complex, you get if, else, elif, etc. Whenever a function first encounters a return statement, that's the signal for the function to stop. It returns a value and basically says, my job is done. I'll stop doing anything here. So that's something to keep in mind. All right, and something that probably actually came naturally to you by this point. We have 4 little indents, 4 little spaces here, an indent by 4 spaces. So just like with a for loop or an if statement, basically everything that happens within the function is under the scope of this definition, and we see this by means of a 1 level for white space indentation of this kind of code. And then, sometimes you will have for loops in a function or an if statement in a function. And if that happens, these again sort of have code that's under their scope where you need additional levels of indentation. When writing a function in the command line, which typically you won't be doing, functions are very much something, given their nature, something that you'll write in a script, but sometimes you'll write in a script and maybe try to copy the whole function over into the command line to see if it's doing what it's supposed to be doing. when using or when defining a function in the command line in the live interpreter, basically, um, you can't have empty lines in there. As soon as there's an empty line, the whole thing will Python will essentially read this as the function definition is over. And if that's not the case, if you actually don't want it to be over, that's going to cause a problem. So just be aware of that. But typically, it's not going to be a big issue because you'll be writing these in scripts and working with them in scripts. So now we've defined a function. How do we call it? It's really simple because it has a name and you call things by their name, right? So here there's a new function. We define this as TTR text, type token ratio in a text. Take the text, split it, which returns a word list. Then we sort of clean up the word list, kind of getting around working with an import statement by kind of spelling out the punctuation characters here, lowercasing it, and then we return the set, the length of the set based on this word list divided by the length of the list itself. Right, so this is, you should get what's going on in this function by this point. Now we've defined this. It's not doing anything yet. It's basically just a recipe for Python to do something. Uh, we actually want to do something with it. We need a text, right? We need something to fill this parameter. So we can have the text, how much would a woodchuck chuck if a woodchuck could chuck wood? And that's our text. And we just feed that to the function. So calling the function is just using its name, always with parentheses. If it doesn't have arguments, it's just going to be empty parentheses. Here we feed it the argument woodchuck, and then it's going to execute. And let's maybe quickly do this to see what it looks like. Right. So defining TTR here. Yep, it exists. And then let me just quickly copy over these two lines. So you've got the text, how much would a woodchuck chuck, and then we just call the function TTR woodchuck, and it tells us that it's about 70%, or 0.67 is the type token ratio for this literary masterpiece that I used as an example here. So this shows you how functions work in action. Again, this sort of in the command line, this isn't as impressive, but as you script and as I mean, we've seen a couple of things we tend to want to do over and over and over again, right? We tend to want to turn a text into a word list, clean that word list, calculate something like mean word length, etc. All of this you can define once as a function and never worry about it again, basically. Just use these function definitions from there on. But the following will cause an attribute error if we do TTR7. This is what I talked about earlier. Let me quickly go into the shell once more. So TTR, let's go crazy and use 8. We get an attribute error. Integer object has no attribute split. And if we go back to the function definition, it takes something called text, and in the first line of the function itself, we get text.split. And that doesn't sit well with if we feed it an integer value. And so we need to be aware of what the values are that we can and should feed to our function. So we need a bit of an understanding of what the functions do. Before we talk more about this, time for a quick exercise. Just a few function definitions, basically. Do this in a script. Define a function that takes one argument and expects that argument to be a string. And then the function should return just the first character in the string. That's all the function does. For a bonus, you can have the function return the set of all characters in the string that are not alphabetic. So any unique character that isn't an alphabetic character looks maybe slightly more useful. And for the second bonus, write a function so it takes a second argument, so 2 parameters, and that should also be a string, and have the function return a count of how many times the second argument occurs in the first. So the first is probably going to be a longer string, and the second argument might be a word or a multi-word pattern that you search for in this longer string. As always, pause here to run the code and scroll down in the HTML slides to look at what a solution could look like. But I'm going to continue right on. So this is now your time to pause the video. And here we go. A little bit more about parameters. Anything that goes in these parentheses in a function definition is its parameters, right? And that can be, in principle, an almost infinite amount of things, but very typically, you rarely ever see more than 3, honestly. Right? We can have something. 2 is quite common. Do something like relfrec word text, and then we word and text. We sort of have helpful variable names here or parameter names because they help us get a sense of what we're looking for. We're searching for a word in a text, right? So clean word list becomes just the cleaned and split text. And then we just basically count how often the word occurs and what fraction of all words in the text that word is. That's actually a pretty sensible function to define at some point if you're working with language data. So it's not necessary that you specify what type the arguments should be, right? Nowhere in that function definition is it specified that word is a string, the text is a string. But as soon as you do something with these that doesn't, a method that only works with string, when you call the function and you feed an integer or a tuple or a list um, to it as an argument instead of string, and then it does dot lower, that's when Python is going to complain. And one way around of this, oh well, let's first look at the kind of notational difference between parameter and argument. And really, I'm just going to leave this quote here. Parameters are the names used when defining a function or a method, and into which arguments will be mapped. In other words, arguments are the things which are supplied to any function or method call, while the function or method code refers to the arguments by their parameter names. That really all that's saying is that when you define the function, the thing that goes in the parentheses technically is called the parameter of the function. But as soon as you actually call it and feed it something specific, this becomes its argument. That specific thing is the argument that fills the slot of a particular parameter. This is not super consequential, but you'll hear both of these terms, and maybe a good idea to keep them apart. You can think of parameters like loop variables, right? You can call them whatever. And when using a function, you typically won't even know what the parameter names are, right? Because you'll have encountered the function as, TTR my text, right? So in its specific application where you don't see the underlying parameter name, but sort of the specific value that's being given to the function, or the name of the variable storing the specific value that's being given to the function. It's quite common for me to work with with modules, with functions from modules where I don't actually know what the parameter names are, because I look at the documentation and I see the example. Okay, you call this function in such and such a way. Here's an example sentence. This is how you use the function with this example sentence, etc., etc. So that just highlights kind of how irrelevant it is what precisely a parameter is called. The logic of the function is what's important. And in order to sort of not keep all of that a mystery, it's a very good idea and something where I'll be the first to throw myself under the bus because I don't do it a lot. It's a very good idea to write documentation for your functions. So here we have a function. I mentioned something along these lines earlier. It's called hello. It doesn't have any parameters. And then there's these 2 lines here. It just enclosed in 3 quote marks. This is a function that greets the user. It does not take any parameters and is generally useless. And then it actually does something. Name input, what is your name? So it's going to ask the user the name, and then it's going to print a hello and greet the user by their name. So very quickly to see how this docstring is useful, let's switch to the shell, shall we? And kind of copy this definition here, right? So now we can call it, and it says hello Axel. How nice. But assuming we are aware that there's a function called hello and we don't know what it does, that was a bit fast. Let me exit again. We can click help, or not click, but type rather, help, hello, help, name of the function. This should look familiar, right? We've done help something before in the homework exercises and sometimes also on the slides. And this will take you to the documentation for the function. Hello, this is a function that greets the user. It does not take any parameters and is generally useless. So just what we wrote into the docstring is being shown here to the user. If you ever write code where you want others to understand what's going on, or if you really consider it to yourself and want to document what you're doing, this is a great way of doing it using docstrings. All right. Yeah, pretty much said all of that. There's a couple of things you write into the docstring, right? What the function does, so its general purpose basically, what it expects as input, so what the individual parameters are meant to be when you feed arguments to them, and also what the output is going to look like. And ideally also kind of what format the output is going to be in. So ideally, if I never execute the function and just type help function name, I should have an understanding of what actually goes on in the function. That would be ideal for a docstring. Let's do some more practice. This is not about docstrings. It's just a bit more of getting our code in general to work with functions. So this is from the last homework where we calculated the average word length, average sentence length, and type token ratio for each corpus text in, or each sample in Brown. We can rewrite this code and put functions to some good use. So you can define functions here, mean word length or mean WL, to calculate the average word length based on a word list, I would suggest. Mean sentence length or mean SL to calculate the average sentence length, and TTR to calculate the type token ratio. And then once you've defined these in your script, iterate over the corpus. And really, I mean, for the purposes of this, just one file, Brown A is enough, which has several corpus samples in it. And use the above functions here to write the results. And maybe you'll start seeing how these functions are really quite useful. Again, pause the video, take some time with this. This may be something where you'll actually not pause the video and try to do it all and then come back to the video, but where maybe you want to give yourself a bit of extra time after finishing the video to complete this exercise. But do it in your own time, which whatever way works. A final bit, and I hadn't really planned to talk about this, but I've seen it in code that some people have used for homework exercises where they looked up solutions and found stuff online. And that's this notion of main. Very often you'll see this def main. And that's typically associated with a line that says, well, you can read it here in line 5, if underscore underscore name underscore underscore Boolean equals main with also these underscores, then execute the main function. This is generally something we're not going to touch in this introductory course, basically. But since it's already kind of made its way in, I felt it's a good idea to talk about it a little bit. Main here really is just a function definition, right? Anything down to line 3 shouldn't look in any way out of the ordinary after what you've seen in this video, right? We have a def, the name of a function happens to be called main here, but it could be called Susie Jew as well, or whatever. It doesn't take an argument, colon, does something, returns something, etc. This is just a function. So this is not actually something to really focus on. But here's something, underscore underscore name. And that's something quite specific. It's a variable that is set whenever a Python script, so anything, any file .py, is in any way kind of read in. And there's basically two ways for a file like that to be read in. We've only actively encountered one, and that's doing Python name of script.py, and then it's actually run. And if that's the case, then this name variable is set to main. Basically, if that's the case, we're executing this particular script. Another way of reading in a .py script is with the import statement. We've actually seen this, but we haven't really talked about the logic that there's an underlying .py script. But when we do something like import string, import OS, right? We're really referring to a file on the computer that's called os.py. That's called string.py. And that's then read in, and we can use functionality from that. And if we do that, if we do import name of file without the py, that sort of is left unset essentially, then name is set to the name of that file, again minus the py. So essentially, when we're typing in the live interpreter import OS, Python reads the file os.py and reads it. Everything while it reads it, it has name set to OS and not to main, right? So if there should be any line that says if main execute some code, that code is not executed while we're importing this. All of this is very kind of, well, it's not very, but it's kind of complex to kind of wrap your head around, and it really only becomes relevant once you start writing functionality in Python that sort of spans several scripts, right? Where you have one script that actually executes your code and several other scripts that just provide that you import that provide functionality. It's not something we'll really focus on. It's not something we'll really use. I've seen it used, and I've even read some people basically saying that IT friends recommended this be used. I'm sure they have good reasons to recommend that in a very general sense, because that's how programmers often work. But I think we're doing ourselves a favor at this stage to kind of to ignore this and stay within one script, and that's the script we're going to execute, where we don't need to worry about checking whether name is main or not. But if you want some practice, here's some practice for this as well. So write a script that has a couple of functions, word list, frequencies, that just kind of do what's described here, and then a function main that uses the above functions to return a frequency distribution of all words in Shakespeare. And then include an if statement that executes main only if name is actually main. There's a typo here. This should be main underscore underscore. I'm going to fix this in the HTML slides. And then what this script does is basically you can execute it and get all of the frequency distributions for Shakespeare, if that's what you happen to want to do. But you can also import the script in any other script where you want frequency distributions based on a text, and use its functions, word list, and frequencies to achieve that. So that's kind of an example of how using name and checking for whether name is main kind of makes sense. But again, this is sort of kind of pushing beyond what I had in mind we would be doing in this introductory lecture anyway. So play around with it, but don't stress out over it. It's not going to be part of the homework exercises either. And that's all, folks. We're done for today. All hands free, which is convenient because Pythons don't tend to have hands. Here are the image credits and the links to everything. Not the answers, but at least the links to everything. See you for the next video. Bye bye.